Welcome to Narayana Group. This is Ram Babu, Senior Faculty of the Narayana Group. And now we are going to discuss the yesterday's paper, uh, 1st February afternoon session paper. This paper is completely developed from the students' memory only. So, in the original paper, questions may be differ from these questions also. Now, we are starting the first question. Ratio of the acceleration due to gravity on the surface of the planet 1 and planet 2 is x, while the ratio of the radii of respective planets is y. The ratio of respect to escape velocity on the surface of planet 1 and planet 2 is equal to. Now, first of all, it is completely from the gravitation only. Now, the escape velocity formula, we know v is equal to under root of 2zr. Now, acceleration due to gravity on the surface of planet 1 and planet 2, they are different from each other. And the radii of respect to planets is also different. So that's why you can write the ratio v1 by v2 is equal to, you can write under root of g1 by g2 and r1 by r2 we can write here. Now that should be equal to that of g1 by g2 ratio is x and r1 by r2 ratio is y. So v1 by v2 ratio is equal to under root of xy is the third one. Next question. So in the second question, it is completely purely from the atomic physics. In a hydrogen atom, an electron makes a transition of third exit state to ground state. Find the energy of the photon emitted. Now, third exit state energy of the hydrogen atom, already we know, third exit state is nothing but the corresponding n value is 4. So, this is equal to minus 13.6 by 4 square only. Similarly, the energy corresponding to the ground state is nothing but, we know, minus of 13.6 by 1 square electron volts is also electron volts. Now, as it is jumps from the third to ground state, the energy released by them is nothing but E is equal to h nu, that should be equal to that of minus 13.6 1 by 16 minus 1. This is equal to minus 13.6 minus 15 by 16. So total one 13.6 into 15 by 16 electron volts. So it is very close to that of 12.75. 13.6 into 15 by 16. By means of answers also, we can calculate that point. Now we are going to the next question. A uniform rod of mass 10 kg and length 6 meters is hanged from the ceiling as shown. Actually, we missed the diagram also. Given area of cross section of rod 3 mm square and Young's modulus is given, find the extension in the rod's length. They are asking. Now, this is purely from elasticity chapter, that to Young's modulus. So already we know, here they are asking, find the extension in the rod's length. Direct formula we have, extension E is equal to FL by AY. It is suspended from the rigid support. Uniform rod of mass 10 kg and length 6 meters is hanged from its ceiling. As shown in the figure. Given area of the cross section of that rod, Young's modulus is 2 into 10 to the power of minus. Means here the rod is extended by its own weight. So that's why here everyone has to calculate very clearly. The basic formula we have to change the small one, dE elongation in the small length y. Whereas here we are considering such a way, this is the y, this is nothing but dy only. This is the, now we want to calculate the elongation in this small part of length dy. Here one more point we have to calculate this weight here, the tension at this region is equal to T at this point. For example, this is the point P. The tension at the point P is equal to the due to the lower weight. So the weight of this part is nothing but total weight is considered as capital M. Now this part of this weight is nothing but we can write such a way M by R. M is the mass per length L. Total length is considered as the L. So this is the length of L minus Y only. This is the length of L minus Y only. Now weight of this one is nothing but M by L of L minus Y into G is the tension at the point P. Now this is the tension at the point P is nothing but the force applied on this element for the elongation. So instead of this force we have to apply that point only. So the elongation in this part is equal to dE is equal to, we can write here F is equal to, we can write M by L of AY. Already we are containing the same part, and the remaining part of that one is nothing but mg, and we are writing here L minus Y into dy only. So here mg by L of mg by L ay of L minus Y into dy only. Net elongation E should be equal to that of mg by L ay integration of L minus Y into dy. We have to consider the limits of Y. Limits of Y means here the total object starts from Y is equal to 0 to this end completes with this end is completely with Y is equal to L only. Now the limits of Y should be 0 to L. So now the calculation part of this one is equal to mg by L ay. So integration of this one is nothing but already we know Ly minus y square by 2, 0 to L limits. So this is equal to that of mg by L ay. So after substitution of this one we know this is nothing but L square. This is nothing but L square by 2. Finally we are getting L square by 2 only. So this is nothing but we can write here mg L by 2 ay. Actually this is the integration process. Instead of this one also you can write directly. Due to its own weight, the force can be considered such a way Instead of F directly you can write mg by 2 also. Now just substitute the values and find the remaining thing only. Whereas E is equal to, substitute the values. M is equal to 10 kg, G value also 10, and L is nothing but, rod length is nothing but 6 meters by 2, area of cross section 3 millimeter square, so 10 to the power of minus 6 into y, Young's modulus is 2 into 10 to the power of 11. So after the calculations, this is the 2 and 2, this is the 3, this is the 3 and this 2, this 6 is gets cancelled. Now final one, this is the 10 to the power of minus 6, 10 to the power of 11, 10 to the power of 5, 10 to the power of 5 only. So this is the 10 square. Finally we can write here 10 cube by 2 only. 10 cube by 2 is nothing but, we can write 0.5. 10 cube by 5 meters is nothing but, millimeter by 2 is nothing but, we can write B option 0.5 mm. Now next one, we are going to discuss the next question only. For a heat engine based on Carnot cycle, source is at a temperature 600 Kelvin. Now if source temperature is doubled, then efficiency also gets doubled while keeping the sink temperature same at x Kelvin. Value of x is equal to. Now this is the purely second law of thermodynamics. Efficiency is equal to, we know the formula, 1 minus of temperature of sink by temperature of the source only. Temperature sink by temperature of the source only. Now here we have to substitute that one only here. In the first case, the efficiency is considered as certain eta is equal to 1 minus temperature of sink is same at both the cases. Keeping the sink temperature same at x Kelvin. So this is the x by initially that is the 600. This is the new one. N dash is equal to, it is the double of this one. Efficiency is doubled when the sink temperature is, that means this is nothing but, we can write here the sink temperature remains same, but the source temperature is doubled, is nothing but 1 by 1200. So this one, as per this one, we can write here 2 eta is nothing but, we can write 1 minus x by 600 of 2 is equal to 1 minus x by 1200. Now 2 minus 2x by 600 is equal to 1 minus x by 1200. So this is nothing but, we know 2 minus 1 is equal to 2x by 600 minus x by 1200. This is nothing but x by 300, or directly you can write here 900 by 300 into 1200. Already you know this factor. So x take common, and after subtraction of the vectors, values. Now 1200 minus 300 is 900. This value we are getting. This is the 3 times. Again this one is calculated 400. Now this is the x is equal to finally 400 Kelvin. That is the value we are getting. This is the fourth question. Next, we are going to the fifth question. It is a purely from the ray optics, that too on the mirror concept. Already, two object points 1 O2 are placed on principal axis of concave mirror of radius of curvature 40 centimeter. Find the distance between the two images. Now, image distance we have to calculate. Here, observe the points. Basically, what is the formula for this case? 1 by f is equal to 1 by v plus 1 by u. This is the formula. Now, that's why you have to calculate the v values only. That's why I am substituting like 1 by f minus 1 by u. And moreover, we can write the formula v is equal to uf by, after the calculation of this part, you know, u minus f. Now I want to use this one. But focal length of the concave mirror, already you know, the focal length of the concave mirror f is equal to minus r by 2. As for that one, here this is the minus 20. And already you know the different values of u. Therefore, v1 and v2 we have to calculate u value. Before that means this is the ray diagram, already you know, the sign convention also you know. This is the incident ray direction. Object is opposite to the distance of the object is opposite to the incident ray direction. Thus u value also negative. U value for the first case, if you consider O1 case, then there is the 25 centimeters minus 25 you have to consider, since it is the opposite to the incident ray direction. And the focal length is minus 20 only. By here, this is also minus 25, minus of minus plus 20 only. Total together, here this is the 25 into 20 by, this is nothing but minus 5 only. Totally we are getting here, this is the 5 is the 4 times minus of 100 only, 100 centimeters. Negative sign indicates this side only. Okay, next one. What about the second one? Second image, due to the O2 object. This is also you can calculate such a way. This is the u1 is nothing but minus 15 centimeters. This is also the negative. And this is equal to minus 20 only. By this is equal to minus of 15 minus of minus plus 20 only. Total one is equal to, here also you can write is the 15 into 20 by plus 5 only. So this is the 3 times we are getting plus 60 centimeters only. So as per the diagram under this one, V1 is a minus 100 centimeters, means the image due to O1 forms this side. That is nothing but, we can write the image position. This is the I1. The distance of this one is the 100 centimeters. While the V2, the distance, the image of this one is the O2, that is the I2 only. The distance of this one is the 60 centimeters, since it is the positive. Now the separation between the I1 and I2 is nothing but, total one is the 100 plus 6, 160 centimeters only. This is the fifth question. Now I am going to say next question. A train moving with initial speed 20 meters per second applies the brakes to stop at the incoming station, which is 500 meters ahead. If brakes are applied after moving 250 meters, then how much beyond the station train would stop? Actually, is the I think some of the information may lost in the question. Okay, what it may be? A train moving with initial speed means, for example, this is the path. Initial speed of the train is 20 meters per second. Initially, the distance of the station is 500 meters. But a train moving with initial speed applies the brakes to stop at the incoming station. But here, the capacity of the brakes are not given. But as per the question, we can take the information such a way. Here, the brakes capacity, or if the brakes are applied, the train comes. That means we can imagine. We can take the information such a way. If the brakes are applied at a distance 500 meters before the station, it will comes to the rest at the station only. So, as per that one, we can write here. Initial is the 20 meters per second. This is the 0 meters per second of traveling of this 500 meters. For example, this is the station. But the brakes are applied after 250 meters. Means it comes to rest after traveling through the distance 500 meters. Means here it comes to rest after the which distance only? This is equal to the 250 meters only. Then how much beyond the station train would stop? So this is nothing but what is the value? This is the 250 meters only. We can take that is the 250 meters. Next one. We are going to the next question. Here also, look at the question. Purely it is the current electricity. Now, look at the diagram here. The circuit based question. Consider the following circuit. All resistors have resistance 10 ohm each. Find I1 plus I2 by I3. So, in the diagram, this is the I1, this is the I2, this is the I3 only. Okay. As per the nodal method, directly we can calculate. Let us consider such a way. The potential at this end is considered as the 0 volts. Automatically the potential at this one is the 2E only. And actually it is the, look at here, 0 to it is increased by, potential is increased by 2E. And again here the potential is decreased by E. So at this point the potential is equal to decreased by, that means it is crossed here. We are crossing from higher potential to the lower potential. That's why it is the E only. This is the 2E, this is the E only. So at the same time, these are the only the connecting wires. You know, this is the E also. This one is also equal to the 2E. And again, this end is the 0 volts and this end is the E volts. We know very well. Each and every resistance is the R only. Now directly we can apply I1 is equal to. But here, one thing everyone has to observe very clearly. Here the arrow marks are like this. Means towards right to us. But here we are getting, this is the higher potential, this is the lower potential. That means as per this one, the current will flow from this end to this end only. Should flow from this end to this one only. That's why here the imagination of the currents are wrong we are considering. So that's why I1 is equal to, we can write 2E minus E by R only. But original one is the opposite to the current only. That's why I am taking like this. So this is equal to minus of E by R. Why I am considering the negative sign here? Simply, that is the opposite to the given diagram direction. Similarly, I2 is equal to, here also same resistance. So this is also flows in the same way. Same answer we are getting E by R. But I3 is equal to, think about I3. What is the I3 value? Here the current direction is like this. And moreover, as per the diagram also, this is the higher potential, this is the lower potential, we know. So direction of the current is correct. So I3 is equal to, we know, this is the E. The difference is E by R as per the Ohm's law. V is equal to IR, I is equal to V by R only. So finally they are asking, find the ratio of I1 plus I2 by I3. Modulus of, they are asking I1 plus I2 by I3 only. So that should be equal to the E by R plus E by R by E by R. So this is the minus E by R by E by R. But this is the modulus we required. So this is simply we can write 2 only. So the now answer is the A, 2 only. Next one, we are going to the next question. 8th one. It is a purely assertion reason question only. And moreover, there is a one more question from the current electricity. For making a voltmeter, we prefer a voltmeter of resistance of 4000 ohm over a voltmeter of resistance of 1000 ohm. Now, first of all, think about the voltmeter. Purpose of voltmeter. Purpose of voltmeter is nothing but, by means of voltmeter, we can calculate the potential difference between the 2 points in a circuit. Okay, when the voltmeter is connected, what will happen in the circuit? Let us consider this is the purely one resistance and this is a circuit, one of the circuit. Let us consider this is the R, internal resistance small r, and E is the cell EMF. Now, without any voltmeter, this is a circuit. Let us consider the same circuit with voltmeter. Resistance of the voltmeter is considered as RV between the same points A and B. One thing everyone has to observe very clearly here, effect resistance between V is equal to V across AB. Original one is the I into R. Here the I is the current flowing through this one. But E is equal to, what is the E value? Sorry, what is the I value? E by total R plus R of into R only. That is the current flowing to the circuit. But here you can observe in the same case, now the current is I dash is the differ from this one. Why? Effect resistance between A and B is the variable. Here effect resistance between A and B is the only R. Here due to this one, this is a variable. Now here 1 RAB is equal to 1 by R plus 1 by RV. And moreover, we can write here V across AB dash. Now the potential difference between the AB dash becomes, what is the value? I dash into R across AB by, actually sorry, that is the point only. I dash into R across AB. But I dash is nothing but what? I dash is nothing but new current flowing through this one. This is nothing but E by total resistance in the circuit. This combination again is parallel to this one only. So the net potential, the net resistance between A and B is considered as RAB. Then this is will be the R plus RAB of RAB. But one thing everyone has to observe very clearly. VAB dash. This is the VAB. Now this can be written as such a way 1 plus R by R. This can be written as such a way VAB dash becomes such a way E by 1 plus R by RAB. But one thing everyone has to observe, in the parallel combination of resistance, RAB should be less than R and it is also less than RB. RAB less than R and RB less than RB also. One more thing we have to calculate, means RAB should be less than R. As RAB less than R, this total factor this total one, as RAB less than R, this total one R by RAB should be greater than R plus R. R by R. And this is the greater, total denominator is the greater, this total one is the less. Once again, RAB is less than R by RAB greater than R by R, total denominator is greater, total value is the less than that of this value. Means we can say VAB dash is the less than VAB. But one condition, accuracy. We have to think about and we have to discuss about the accuracy. Means VAB dash tends to VAB at the condition RAB tends to R. When RAB equal to R or RAB tends to equal to or tends to R, then only VAB dash tends to VAB. As RAB, but one thing again here, concentrate about this factor also. Here you can observe RAB tends to R when RV is at infinity. RAB tends to R at RV is equal to infinity only. That's why we have the statement also. For large resistance of the voltmeter, we can calculate the accurate values of the potential differences. Now here they are saying first one is the 4000 ohm and the second one is the 1000 ohm. As the 4000 is higher than that of the 1000, we can, that means the higher resistance voltmeter is preferable to the calculate the potential difference between the any 2 points in the current, in the 2 points. The second one, actually there is the reason here. Now concentrate about the reason. Voltmeter should be higher resistance such that it draws the less current automatically, we know. As this one is the higher, automatically the current drawn by this one also very less. There is also the correct reason. So A and B both are correct and correct explanation. That's one we have to choose. A and Both are true and R is correct explanation of A. That's the answer for this question. Next one, we are going to the next question. According to the shown PT graph, means here I think we are missing the graphs. Okay, but I have certain idea about this question, so I'm drawing that graph also. Look at here. PT degree Celsius graph. After the discussion with the certain students, I got this question. I am writing this one also. So here, okay, actually this is the graph for three different gases. But whatever it may be, all three different gases have the P pressure on y-axis, temperature degrees Celsius on which one only, particularly x-axis. Okay, all these curves are intersect the temperature at a single point only. According to Charles' law, already we know, or from the ideal gas equation also, we can explain the same points. What are those points? PV is equal to nRT is the ideal gas equation. We know as PV is equal to nRT. P is equal to nR by V into temperature. But everyone has to observe this temperature should be the absolute scale of temperature only. Now P is equal to, we can write nR by V of T degree Celsius plus 273 only. Now everyone knows very clearly this is the depends on the number of moles or what it may be, the slope may be they're different, depends on the nature of the gas or what it may be. These are different, but the intercept temperature means temperature intercept is nothing but what? As per this one we know the temperature intercept, that means the temperature axis intercept is minus 273 only. This one is the 0 degree Celsius. So this is the correct answer. Okay, now we are going to next question. Okay, this is again from elasticity only, purely, and previous is same as that of the previous model only. But here the rod is horizontal, two end forces are acts, both are same in magnitude but opposite in directions. Now we want to calculate the, here also we have to calculate the which one only, find the elongation. Look at a wire of length L, cross sectional area A is the pull dash shown, Y is the Young's modulus of the wire, and find the elongation of the wire in wire F, A, L, Y are given. Now concentrate. Here also actually the basic formula for the elongation is nothing but D is equal to F into certain dy, or we can take it as dx by ay, where x is nothing, dx is nothing but we have to consider certain element of length dx at a distance x from one of the end. But one thing here, the forces acts on the same one. The forces on the rod are same at both the ends. The tension at every cross section should be the same. Already you know the point. Since what is the acceleration? Acceleration of this one is the 0 only. Now the tension at every cross section T should be equal to the F. only another point. So accordingly, we can write the points here. This is the as the tension is nothing but F only. This is F, we can write the tension also. We are continuing the same one F. And moreover, net elongation is equal to F is the constant throughout every point. That is also very important. There is no variation of the tension. Tension at every point, T is equal to F is the constant. That is the constant. That is the constant throughout the rod. As F is the constant, A is the constant, and Y is the constant, then we can take only the integration of dx from 0 to L only. So that should be equal to that of F into L by AY. So directly apply the formulas for values of the different one by one. F 100, L 1 meter, A 10 centimeter square, 10 into 10 to the power of minus 4, Y Young's modulus 5 into 10 to the power of 10. So 10 to the power of 10, 10 to the power of 11, 10 to the power of minus 4 is nothing but we can write here 10 square by we can write here 5 into 10 to the power of 7. So final one, this is the 1 by 5 is the 0.2 into 10 to the power of minus 5. So what is the answer here, corresponding answer? We can write here 2 into 10 to the power of minus 6. This is nothing but we can write here 2 into 10 to the power of minus 6. This is the final answer. Next one. We are going to the next question. In a YDAC setup, a mica sheet of thickness T and refractive index mu is inserted in front of one of the slits. Find the number of fringes by which the central fringe gets shifted. Okay, lambda, D and D are given. Okay, concentrate about the first of all. YDAC experiment. S1 and S2 are the slits. The mica sheet is placed on one of the slits. Without mica sheet, after the mica sheet, okay, now the shift one we have to calculate. Actually, this is the shift is the Y. Already you know as per the formula and conditions. Okay, look at here. Without mica sheet, the central bright fringe formed at O. With mica sheet, the central bright fringe is formed at O dash. Central bright fringe is nothing but what is meant by central bright fringe? Where the central bright fringe is formed. What is the condition for central bright fringe? The path difference between them should be the 0. The path difference between S1P and S2P is a 0. But due to the mica sheet, what will happen? Certain path will increase. The path will increase due to the mica sheet. So what is the path will increase? What is the increase in path? Increase in path due to mica sheet. What is the value? That is the mu minus 1 into T1. That is the increase in path due to the mica sheet. But geometrically it is increased. Actually, when we observed S1 O dash and S2 O dash, geometrical lines, which is the dominating, it is the dominating. How it is the dominating? If this distance is the D, so S1 O dash and S1 O dash and S2 O dash, the minus of this one should be equal to that of which one only? D sine theta only. As the theta is the very small, we know this is also equal to the point D tan theta, this one only. This is nothing but approximately this is equal to D tan theta. So that is equal to, where tan theta is nothing but, we know this one, tan theta is equal to y by, this is the capital D. So this is nothing but, we know, D into y by capital D. Means actually here geometrically it is the dominating, optically it is the dominating. Now for the path difference, net path difference should be delta x should be the 0. That implies delta x is equal to 0 means mu minus 1 into t is the optical path, optical increase in path due to the mica sheet. There should be differences now, d into y by capital D, that should be 0. So mu minus 1 into t should be equal to that of d into y by d. But y is nothing but, they are asking in terms of the number of fringes shift. So if n number of fringes or shifts, n into beta value you have to write instead of y. That should be equal to that of d by capital D of n into lambda into capital D by D is the formula for the fringe width. Already we know. So this D and gets cancelled. So n lambda, mu minus 1 into t should be equal to the n lambda. Therefore, we can write the value n is equal to mu minus 1 into t by lambda only. This is the formula we know. So this is the answer we have to. Second one is the answer. Next, we are going to the next question. For a photoelectric setup, threshold frequencies is F0. For incident frequency of 2F0, stopping potential is V1. For incident frequency of 5F0, stopping potential is V2. Find V1 and V2. So, relation between the stopping potential and incident frequency we are required. First of all on the basis of Einstein's theory of Einstein's equation, EV0 is equal to, we can write here, h nu minus h nu naught. But what is the 1 by 1 factors? Where h nu, what is the h nu? H nu is the incident photons frequency, incident photon energy, nu is the frequency of that one, and h nu naught is the work function, and EV naught, V naught is the stopping potential, is the charge of the electron. We know. Now I am using that factors only. EV naught, they are asking about the stopping potential. Stopping potential is V2. In the second case, V1 is the first case. So I am writing that one. EV1 is equal to, in the first case, the threshold frequency is F0 they have given, means minus of HF0. But incident frequency in the first case is 2F0. So this one becomes 2HF0. In the second case, EV2 is equal to minus HF0, that the work function is remains same as the material is same, and incident frequency is 5F0, so this becomes 5HF0. So the result of first one is HF0, the second 4HF0. So they are asking about V1 by V2, so directly you can calculate that's one also. So that should be equal to that implies V1 by V2 is equal to, you can write final answer is equal to 1 by 4 only. This is the fourth option, 1 by 4. Okay, next one. We are going to next question. Now, this is a purely friction question only. A block is acted upon by a force of F as shown. If M is equal to 10 kg and coefficient of friction is 0.25, find minimum value of F. Minimum F so that the block slides. Okay. First of all, draw the free body diagram of this question. In this one, components F cos 30 and this is the F sin 30. And moreover, we can draw this one mg normal reaction is also upwards. The block is acted upon by a force F as shown in the figure. Coefficient of friction is given. Find minimum value of F. So here the tendency of this one is in this direction. The friction force on this one should be in the backward. The friction force. Now, already we know the conditions. As F cos 30, if F cos 30, that is the horizontal tending force acts on the block, if it is the greater than friction, then only the block set into the motion. So, what is the F value? That means greater than F limit also. Limiting friction. Actually here this is the static friction. No, this should be the greater than limiting friction. Already you know limiting friction formula value also. That is nothing but always we know mu s into, we can write here n value we required here. But here from this diagram n plus f sin 30 is equal to mg only. So that implies we can write here n is equal to mg minus of f sin 30. Substitute here f cos theta, f cos 30 greater than mu s into mg minus f sin 30. That is the condition for motion. Now, if you have considered the same one, f cos 30, what is the cos 30 value? And we have to calculate the f value only. So, f cos 30, already you know, root 3 by 2 should be greater than that of mu value 0.5. That is nothing but we can write 1 by 4 mg 10 into g value we are considering, that is also 10. So 100 minus f into sin 30 1 by 2. So f by 2 of root 3, take this side plus of f by 8 should be greater than that of 100 by 4. We know. So f is equal to f of total one 8. We know the 4 root 3 plus 1 into 8 should be greater than 100 by 4. Now the calculation part is the 25. F should be greater than that of, as per the calculation, 25 into 8, 200, 200 by 1 plus 4 root 3 or 4 root 3 plus 1. So that should be greater than that of that value only. Means here, as per this one, we can write the minimum force of F should be 200 by 1 plus 4 root 3 only. Is the this one. Next question. If universal gravitational constant, Planck's constant, speed of the light are given, so now we want the fundamental, they are considered as the fundamental quantities, the dimensions of the mass we required. It is a purely units and dimensions question only. So as already we know the very good conditions here, one by one. First of all, G. What is the formula related with the G? Already we know F is equal to G m1 m2 by r square. So from this one, G is equal to, we know, F into r square by m1 m2. So from this one we can write this implies dimension formula of G is equal to force m L T power minus 2 r square L square by masses, means here m1 and m2 are masses square. So finally the dimension formula of this one is equal to m power 1 L cube T power minus 2. Similarly, what is the formula, any general formula related to the Planck's constant? Already we know E is equal to h nu formula. From that one we can write h is equal to E by nu. Formula for this case is equal to, we know, energy, that implies we can know energy m L square T power minus 2 by frequency by T inverse. So this is equal to m L square T power minus 1. Next one. Third one is the speed of light. Directly we can write the speed of light is equal to L T power minus 1. Now we want to write here very clearly about the answer. M in terms of G, E and C we have to write. So generally mass is equal to, we can write the general formula G power E and H power B and C power speed of light C power C. That means we can write here m power minus 1 L cube T power minus 2 whole power A H power m L square T power minus 1 whole power B L t power minus 1 whole power c. Now equate the coefficients. Directly I am writing here. Here m power only 1 is there. Directly 1 is equal to, we can write here, minus a plus b minus a plus b only. Second one, here L power is the 0 here, but here L power is the, that means 0 is equal to, we can write here 3a plus 2b plus c. Now last one, t power 0 here on this side, 0 is equal to powers of t minus 2a minus b minus c. Minus 2a minus b minus c only. But this is the second equation, third equation. So second equation, third equation. 3a plus 2b plus c is equal to 0 and minus 2a minus b minus c is equal to 0. From this one we can write here, adding these two, we are getting, this is the a, this is also the b, should be equal to 0. A plus b is equal to 0 from the second and third. And moreover, already we know a plus b is equal to 0. A plus b is equal to 0. And this one is the minus a plus b is equal to 1. From these two equations we can write 2b is equal to 1 only. Already we know this one from this one. Therefore we can write one by one final values. B is equal to 1 by 2. As the b is equal to 1 by 2, a is equal to minus b, so that is equal to minus 1 by 2. And from these two equations we are substituting, and c is equal to, here in the second equation we are getting in the second equation to get the second c values or in the first equation also, 3 into 1 by 2 plus 2 into b is equal to, sorry, a is equal to minus 1 by 2, 2 into 1 by 2 plus c is equal to 0. So finally what we are getting, minus 3 by 2 plus 1 and c is equal to 1 by 2 only. So final answer is nothing but, simply we can write here, final is the a is the minus 1 by 2. A is the minus 1 by 2 means the power of a, this one is the minus 1 by 2. B is the b value minus, a is the minus 1 by 2 and b is the 1 by 2 and c also 1 by 2. So this is the denominator, g should be the denominator and hc and the numerator. The final answer is equal to, we can write here, m is equal to, we can write here, under root of, b and c are positives, so h and c by, we can write here g only. Under root of hc by g, that is the fourth option is the correct answer. This is the way of approach of the question. Now next question, we are going to the next question. For uniform disk, moment of inertia about the diameter is mr square by 4, where m is the mass and r is the radius of the disk. Find the moment of inertia about the tangent parallel to the diameter. It's a purely rotational mechanics and inertia concept only, and very simple question also. For example, this is the uniform disk. Any one of the diameter I am considering here. About the diameter, already they are given. This is equal to mr square by 4. Now I want of this one only. This is equal to always, this is the formula, I is equal to total mass into, this is the perpendicular separation between them as per the parallel axis theorem. I is equal to mr square. IC is nothing but this is the center of mass. So this is equal to, we know, mr square by 4 plus m into r square only. Total one is the 5 by 4 mr square. So now here this is the answer is the second one only. Now I am going to the next question. Here, which of the following graphs best represents the relation between the square of the time period and length of the simple pendulum? Always the graph, to identify the graph, first of all we require the relation between the quantities. Already you know the time period of the simple pendulum. Or the time period of the simple pendulum, t is equal to 2 pi under root of L by G only. Squaring on both sides. T square is equal to 4 pi square of L by G only. Why we are squaring the terms on both sides particularly? Here they are asking the graph between the square of the time period and length of the simple pendulum. That's why we are converting the formula into like that. That whatever it may be, so the graph should be. So this is seems to be y is equal to mx type. So this is the y and x. So this is the y is equal to mx way. So t square term, the t square term on y axis. So this seems to be straight line passing through the origin. So the first option is the correct one. Next, I am going to the next question. Uniform wire of resistance R is folded into a regular polygon of a n sides. Find the equivalent resistance of this system between any two adjacent points. Now, uniform wire of resistance R is folded into a regular polygon. For example, this is the one of the regular polygon. Okay, what are the regular polygon shape? One of the regular polygon. What are the regular polygon? The total resistance of that one is the R they have given. So it is folded like this. If n sides, actually here in the diagram it is the, we have 6 sides, but it is the considered as which one only into a polygon of n sides. Then each resistance becomes what? R by n only. Each one becomes R by n only. Now one more point they are asking between the two adjacent points only. So look at here, any two adjacent points, we can draw the diagram. This is the, for example, this is the A and this is the B. Now This is the point A, this is the point B. This is the one resistance in this direction. The remaining all are. What about the remaining R? So here this is the one side, the remaining sides are n minus 1 sides. So resistance of each one is the R by n into n minus 1 is the remaining sides resistance. This is nothing but R by n only. Now what they are asking, between any two adjacent points, they are asking equivalent resistance. So R across AB should be equal to that of. That is the parallel combination of those two. So what are they? One is this one, another one is this one only. So R by n into R by n of n minus 1 by R by n plus R by n of n minus 1. Simply it is the formula of R1 R2 by R1 plus R2. Already we know. So one of R by n is take common and cancel. Then the remaining factors that should be equal to that of. Which one only? R by n of n minus 1 is the remainder in numerator. And this is nothing but 1 plus of n minus 1. After the calculation of R by n, take common and cancel. That should be equal to that of. Finally, what we can write here? This is nothing but R by n of n minus 1 divided by, this is nothing but n only. So R of n minus 1 by n square is the answer here. So R of n minus 1 by n square is the B option. Now we are going to the next question. Which of the following is correct for Zener diode? Actually, it seems to be direct theoretical question only. Zener diode is always works in the Zener voltage point concept only. Zener voltage, we are getting the Zener voltage at the particularly in the reverse bias only. So look at the options. It acts as a voltage regulator. It always acts as a voltage regulator only. And the second one, it is used as in forward bias. It is used in reverse bias only. So second is the wrong one. But third one is again right. It is used as a switch in series. But here we can choose. It is also the wrong. But finally they are giving A, B, C, D. Out of A, B, C, D, again they are choosing two options. 1 and 4, 2 and 3, like that. But here we have two options only, 1 and 3. So 1 and 3 are the third C option. Theoretical question from semiconductor device. Next question. We are going to next question. Choose the correct statement regarding a ground to ground projectile. Very kinematics question and very easy question also, you know. Ground to ground. Already in these concepts. What they are asking on what they are discussing here, particularly first one kinetic energy question, point statement. Second one is the potential energy statement. Third one velocity. Fourth one also velocity. Look at the first one. Kinetic energy is 0 at the highest point. At the highest point, if it is projected with the velocity v, with the velocity u, and at an angle theta, then at the highest point the velocity is non-zero velocity, and this is equal to u cos theta only. So the first statement is, the first one is wrong only. And the second one, first one wrong. We can choose it. What about the second one? Potential energy is highest. Potential energy is highest at the highest point only. Obviously, that is the, with the increase of height, potential energy value increases, and the highest. This is the highest point only. The potential energy is also the correct one only. So B option correct. Potential energy is the highest at the highest point. Third option. Horizontal component of the velocity increases. Horizontal component of the velocity at everywhere it is the u cos theta only. Everywhere it is the u cos theta only. since the acceleration component in the horizontal direction is a 0. Since acceleration is always a bar is equal to z bar only in the downwards, x is equal to always 0 only. That's why the component is the 0. There is no change in the horizontal component. So this is also strikeout. Vertical component of the velocity remains constant. Actually, acceleration in the vertical direction, ay is equal to minus g, means downwards we can say. So there is acceleration in downward direction, means vertical component is always is the variable. So it is a strikeout. So now the answer is only the B. Final one is the B only. We are going to next question. The electromagnetic wave, the ratio of energy carried by electric field to that of magnetic field. Straight away, this is the theoretical conceptual question. Already we know in the electromagnetic wave, energy carried by the or energy shared by the electric and magnetic fields are always equal. So the ratio between them should be equal to that of 1 only. Always there is a direct question only. Next one. An infinite wire is bent to the shape as shown in the figure with the portion AOB being semicircular of radius r. If current I flows through the wire, the magnetic field at the center O is equal to mu naught I by K r. Value of K is equal to, we have to find out. Okay, I am considering such a way the current flowing through this one is like this. So it is the infinite wire they are saying this is the coming from minus infinity to it passes through unto plus infinity. Okay, I am dividing three parts of the wire. For example, this is the A, this is the B, this end is the C, and this end is the D. One by one. Field due to this part, this right part at this point is the 0 only. Already you know. And the field due to this right part also at this point O is also 0. Here the B due to only circular, semicircular. B due to only semicircular wire only. So B due to semicircular wire is equal to, already we know the formula. For any angle of theta, there is a mu I, general formula mu naught I theta by 4 pi r we know. But here the theta is equal to mu naught I theta is equal to pi only by 4 pi r. Pi gets cancel. So answer is mu naught I by 4r. So therefore we know K is equal to 4 only. This is the numerical question, integer question only. So K is the 4. Now we are going to the next question. If a force F applied on an object moving along the y-axis varies with y coordinate as F is equal to 3 plus 2y square. Okay, this one is moving along the object y-axis, means here actually the direction of F bar is important in case of the work done. Amount of small work done dW is equal to, we know, force into displacement, we know. So here dx, that means it is propagating or it is moving along the only the y direction. Directly we can write dW is equal to F into F bar into dy I cap, dy j cap only. directly you can write. But the most important point is here f bar. We know the limits of y only, we are writing like this. But f bar, the direction of f bar is important. Force F is applied on an object moving along y-axis. Means here we can say the force is applied along y-axis, so we can consider it as per the statements. So then only we can do the question. So as the F is equal to in this direction, then we can write F into dy only. Net work done is equal to integral of F dy only we write. So integral of, we can write 3 plus 2y square of dy only. Limits of already they have given 2 to 5. So that implies we know the integration of this one is nothing but we know 3y plus 2y square by 2. Limits we have to substitute 2 to 5. 2 to gets cancelled already. So the final answers should be, you can write 3 into 5 minus 2 directly I am writing here, plus 5 square minus 2 square only. So the final answer 3 into 3, 9, plus 25 minus 4 is nothing but 30 joules is the answer. Now we are going to next question. The magnetic field induced at the point P on the axis shown in the figure is. So now here the current is flowing in this direction. This seems to be circular coil only. Circular coil behaves as a bar magnet also. From this one we can write the direct formula for this case. B is equal to mu naught by 4 pi into 2m by r cube formula. We can write the actually r square plus, this is the nothing but x, r square plus x square whole to the power of 3 by 2. We can write the formula, where m is the magnetic moment. What is the magnetic moment of this coil? M is equal to, we can write NIA, where N is the total number of turns, I is the current and A is the area. But here only single turn we are observing and they are not given any information regarding the total number of turns also. That's why we are considering those only the single turn, and the current is I and this one is considered as the pi r square. So we are writing here this is equal to mu naught 2 into I into pi r square only by 4 pi into r square plus x square whole to the power of 3 by 2 r square plus x square is nothing but 4r square whole to the power of 3 by 2. So finally this is nothing but 2 times mu naught I by mu naught I into r square by 5r square whole to the power of 2 into 5r square whole to the power of 3 by 2. So it becomes mu naught I into r square by 5 into 5, this one becomes r cube, 2 into 5 whole to the power of 3 whole cube 3 by 2 is nothing but under root of 125. So final one, 1 root of 125 is nothing but 5 root 2, 5 root 5. Total one we can write here mu naught I by, so this is the total one 10 root 5 into r only. So when compared with the answer, here we are getting This is the compare this answer mu naught I by x root 5 into r. Therefore, x is equal to which one only? 10. So, 10 is the answer for this question. The direct application, direct formula only. Okay, thank you.